Thank you for coming. Today we're going to cover hacking modern desktop applications with XSS and RCE, or remote command execution. If you are interested in the slides, the applications that I'm going to demo, to download and play with, so that you can follow the exercises, just send an email to admin@70security.com, and I will be happy to send you an invite to a training portal where all these will be available completely for free, right? So we're going to look at some essentials about auditing Electron applications. Now, we call these modern desktop applications because traditional desktop applications were typically like written in Delphi, then C, C++, and other languages like this. But with modern desktop applications, now we have desktop applications written in JavaScript. So we have people with maybe a web development background who start developing desktop applications and are not very aware about the security model in desktop applications, right? So that can introduce problems, and it's not we're not just covering Electron. So the Electron is like a heavy focus of the training, but what you are going to learn will also work for other desktop applications, because we also look at decompiling binaries and doing other stuff as well. So, but the main focus is going to be Electron and like modern desktop applications. So we're going to check in this webinar what XSS means in a desktop application and how to turn XSS into remote command execution in modern applications, right? So then we will also check attacking preload scripts and remote code execution through IPCs, right? So I'll cover all this now in a bit more detail. About myself, I'm the CEO of 70 Security, security trainer at Black Hat USA, Hacking the Box, or WhatsApp, Global AppSec, and other events. There's some upcoming training courses here, including the session from CIFCON. You can see it all here. I also wrote a course for Electron Security a while back called Practical Web Defense, about hacking and defending web applications. I'm also the OWASP WTF project leader, which is an OWASP flagship project. Some presentations you can see here, and then if we meet someday, I will tell you over a beer how all this certification thing happened. So if you're interested in this presentation, maybe you are interested in reading public pen test reports. So you can see these on the website. So if you go to publications, you have links to all this. So this was an application mandated in South Korea. These were some applications by the Chinese government and stuff. So all these are part of the mobile course, but you have like public pen test reports there to learn more about security and stuff. And this is all available for free as well. So this course has also been written in part by Anirudh Anand. So he's a member of the #1 team for CTFs in India called Team BIOS. Occasionally, he does bounty hunting. So he has found vulnerabilities in Google, Microsoft, LinkedIn, and some other big hitters like this. He has some certifications as well. This is his blog, his Twitter. And then this course was made more awesome by the contributions of these three people answering some of my questions to make things more interesting. So big props to them, and you can follow them on Twitter, right? So especially Masato was very instrumental for some of the attacks in this course. It's pretty cool, as you will see. So to take this course, you're going to need, just some basics, like 8 GB of RAM, 60 GB of 3D space, something like this, right? Latest VirtualBox. For this course, you can use VMware if you prefer. That's not a big problem. And you will also need burp, but again, you can have burp inside of the VM as well. That's no problem. Now, there's a difference with our course from our courses to other courses. It's in a number of things, right? So you get the digital copies of all training material, you get the lab VMs, you get the test tabs, you get the source code of the test tabs. So this is kind of the normal stuff that you would expect, right? But then what is maybe not as normal is that you get lifetime access to the training portal, including all future updates for free, step-by-step video recordings, slides, lab PDF. So everything that we update, we give this training in a lot of conferences all over the world. So the courses keep getting updated, and you can see the last time where each material was updated. You can see the dates. So if you can see that the date is later than when you took the course, you can see like this newer material there or something, right? And you also get unlimited email support. So our training has a lot of material, so people typically never have time to finish it during the class. The reason for this is that we want to keep both new students as well as advanced students happy. So we err on the side of too much material so that everybody's going to be happy. Like, no matter your skill, you're going to learn a lot during the training. And if you don't finish it during the class, that's fine, because you can then continue from home and just send an email. If you're having some issue or you are wondering about something, you have a limited email support. So you still get more than you paid for, because you get like more material than the material that can be covered during the class, right? So that's just to get that out of the way. So the course starts with part one. We don't have, before we call this day one and day two, but it's not possible to do it in one day. So I think part one is more appropriate. So in the first part, first we start with an introduction to Electron. So we talk about reversing the different formats in which Electron applications typically are packaged. But again, these formats also apply to other desktop applications, right? There's other Linux applications in AppImage, there's other Mac applications in DMG, there's other Windows applications in EXE, and then the SR format would be specific to Electron, right? So this is what I meant earlier, that the course covers desktop applications, but not just Electron, but a lot of the techniques that you're going to learn will also be useful against other desktop applications, right? Now we take a look at the Electron configuration, packaging, web preferences, and then we start with an introduction to Electron vulnerabilities, right? Finding vulnerabilities in dependencies, XSS exploitation, exploiting node integration, which we will see today during the demos. Some XSS and remote code execution, mitigation essentials, and then some electronegativity to find some kind of low-hanging fruits and stuff in a more automated fashion. Then Lab 2 moves on to XSS and remote code execution. So bypassing CSP, attacking preload scripts. We will see some of attacking preload scripts today. CSP bypasses. Then we will also check attacking Electron apps on Windows, very important topic. How to attack, like, for example, using Samba shares, about the zone identifiers and how to bypass all those security prompts, how to get remote code execution without warnings in Windows, and then attacking preload scripts and lack of content isolation. Then in Lab 3, we talk about general desktop application vectors. And since this is about desktop applications, we cover the main platforms, right? We are going to cover Windows, Linux, and Mac, right? So we cover all three, and then we look for leaks in the local file system. So local storage, local files, SQLite databases, reversing Electron applications, decompiling binaries. Now, again, decompiling binaries is a skill that we cover in all three platforms and will be useful against other desktop applications as well, just as an example, as well as how to look for these leaks is also like a skill that will be applicable to other desktop applications. And in the other content, like bypassing CSP, is also a technique that will be useful for web application testing, right? So there's a little bit of overlap with other things, right? Then the art of man in the middle. It's a lab where we cover how to intercept all the traffic, how to resolve common problems, do man in the middle with DNS spoofing and tampering with Etsy host and other techniques. So again, pretty cool lab, and again, using Windows, using Linux, and using Mac. So we cover man in the middle on all the platforms, because if you have to test a desktop application, typically you're going to be given 3 builds, one for Windows, one for Linux, and one for Mac. Maybe not always, but many times this will happen. So you should know how to test on all platforms, right? And then the art of repackaging is a lab where we're going to talk about modifying apps, right? Because sometimes we need to modify the app so that it shows more information, or we enable like the dev tools, we change some text, we, for example, soften CSP, or we make other changes so that we can debug the application better. And another thing would be sometimes to deobfuscate JavaScript, right? Because the application is written in JavaScript, so we reverse it, we get the JavaScript back, but maybe the JavaScript is obfuscated, so it's difficult to read. So we will cover how to deobfuscate it, but get the application still to run. And this, then how to put like backdoors inside of desktop applications. So we will cover a Beancap for that. Then we cover instrumentation, right? So in instrumentation, we're going to cover Frida. We will use, now again, we use real applications in this training. There's some toy applications, but all the toy applications are actually implementing vulnerabilities that we have seen in real pen test. So all the vulnerabilities in the course are either a case study from a real application, or a toy application where we simplified a vulnerability that we found in the field, and that you can play with it without knowing which was the affected vendor, right? So in this lab, we cover Bitwarden, which is kind of similar to LastPass. So we will use Frida. We attach Frida to Bitwarden, and then we can trace the generate handlers, modify the handlers to monitor what Bitwarden is doing in real time. We will discover methods. And then we use some Electron-specific approaches to debugging with Devtron and Chrome Inspect, right? So this is all in Lab 6. And then at the end of the day, we will have a CTF. In practice, this is something that people do in their own time from home, because nobody has time to reach the CTF. Nobody's fast enough to complete all the other labs, because there's so much content. But yeah, so that's about that. And then in part 2, which will be the second day, we cover remote code execution and CSP. So there's like a little bit of a refresher about all this stuff in Windows, which is important for this topic. And then we have a case study about remote code execution and CSP bypass with Bitgarden, going into some details about that, which is pretty cool. So again, real case studies with real vulnerable versions found in the field about well-known applications. Now, data exfiltration, the next lab, we will study some drag and drop data exfiltration, as well as some, problem troubleshooting typical when you are engaging in desktop application hacking, right? So repackaging the application in Linux, bypassing some resource integrity, and then the drag and drop XSS and how to do extra and data exfiltration with that. So again, pretty cool lab for all that stuff. Then lab 3 will cover IPC remote code execution. So IPC is basically sending messages. So this will make more sense in a moment, because this is one of the topics we will cover today. Of course, in the course, it's in a little bit more depth, because today we don't have much time. But this is also a cool topic, right? So we have a couple of case studies here. My other wallet, remote command execution with an attack through the preload script. So we have like a lot of exercises and scenarios here, and then again with IPC and middle click remote command execution. And this part we will cover a little bit today. Then we have man in the middle, but with other twists. So in here, we cover like pinning, how to bypass pinning, how to implement pinning, how to disable upgrade checks that apps might have, and other stuff like that. And then last 5 remote attacks is going to be surprising, right? Because you think about Electron and you think about the client, but sometimes Electron applications exist on the server. So if you are a web app pen tester and you have no idea about Electron, you're missing out, because actually we found this like a couple of months ago. Well, I don't remember exactly, maybe 3-4 months ago in a pen test, where a web application was running an Electron component on the server that was generating PDFs based on user-supplied HTML. So we cover here the methodology about if there's a parser on the server, what you can send, and reviewing all the information that comes back, figuring out how to attack it, and read local files and do server-side request forgery and all that cool stuff. And then in Lab 6 we cover local attacks, and we have like a couple of different versions of a VPN client called MoveAd with privilege escalation and leaks, and we attacking local WebSockets and stuff like this. And then again, a CTF at the end, right? So with that, that is what the course is going to be about. And now I'm going to jump into the actual webinar content, which will give you a little bit of a preview about what the training is going to be about, right? So here we're going to cover first hacking modern desktop apps with XSS and remote command execution. So the first thing you need to know about Electron is that there's two types of processes, right? There's the main process and the renderer process, right? So the main process is one, and then this process is going to spawn different renderer processes, right? So the renderer is what the user sees. This is going to have HTML, CSS, and stuff, and the main process is more privileged, right? This is what launches this. But the important thing to remember is that this process has access to a lot more stuff. So if you can somehow, with an XSS or something from here, attack the main process, which we will see a little bit of in one of the demos at the end today, this can be really interesting because we can get like code execution and there's like other possible scenarios, right? It's always going to depend on what the application does, but it's pretty cool, right? So the way it works is there's a main process, there's a renderer process, and this is the IPC part, right? So the IPC is inter-process communication. So it's basically the renderer processes can send messages to the main process, and the main process can send messages to the renderer process, right? So there's some IPCs going on here. So inter-process communication, two processes, and this is the communication with messages similar to Android when you send intents from one app to another. But here it is inside of Electron. Inside of the Electron app, there's messages between these two processes, right? And then there's API calls invoking the Electron functionality. And then at the bottom, we have the operating system that Electron will interact with, right? So the main process, as you can see, has a lot more functionality than the renderer process, but there's some overlap in functionality, right? So there's some functions that both share, but in general, the main process is the one that has a lot more functionality. Okay, so with that, let's start with some essential techniques to audit Electron applications. So the first thing, and now again, if you send me an email, I will give you an invite with the training portal with all these applications. So don't worry about it. And basically, one of the first things that you can do, not just when you audit Electron or Node.js, but any JavaScript app, right? So if it is, for example, a mobile app written in Cordova, or if it is a phone app or Ionic or anything that uses NPM somehow, you can run this command, npm audit, right? And this will give you a list of vulnerabilities affecting the dependencies of this app, right? So this is a quick way to find some vulnerabilities without really doing much, just running one command, right? So we can get this, we decompress it, and then we run npm audit. Then the first time you run it, you can see this error message. And if you pay attention, in the error message is telling you how to fix it. So first you need to generate the package log file. So you do npm i -- package log only, and then this will generate, so you run basically this command, and this will generate the package log.json, which basically resolves all the dependencies in the app, so that npm audit can then check the versions for publicly known vulnerabilities, and then it will give you a nice list, right? So after this, we can run npm audit, and then you will see some output and something like this, right? So you will see a list of all the vulnerabilities because of outdated dependencies, and then you will have a link to the actual advisory, right? So that is how that looks. This is like a little bit reduced because there's no point in listing all the vulnerabilities here. So The important thing to know here, it's only a matter of time until vulnerabilities and dependencies are discovered and made public, and a perfectly secure application could become vulnerable down the line as issues in underlying libraries are found over the years, right? So that's important to bear in mind. And then another thing that you can do is to find vulnerabilities in the actual configuration of the app, right? So if we look at the vulnerable one application, which will be available for those who reach out, you can see the package.json, and then you can see the content. And inside of the content, you will see this, right? You are looking for the web preferences. And here we have node integration set to true and context isolation set to false. Both are insecure settings. And the reason why is this, right? So node integration, when it is enabled, so when node integration is set to true, this gives the DOM access to the Node.js APIs. So this means any XSS can invoke Node.js functionality and then turn any XSS into remote command execution immediately, right? So this is pretty cool for attackers, but for an application, if you really have to have node integration enabled, it's important to check that you don't have any XSS, because a single XSS on the application is going to be game over. It's going to be code execution. And then context isolation, if it is disabled, so if context isolation is set to false, the implications of these are that the Electron APIs and the Preload script run in the same context, right? I will go into a bit more detail about this in a moment with more slides, so don't worry too much about it if you don't fully follow me now. But basically, the idea is that you need this isolation between the Preload script and the page that the user sees, so that if there's an XSS, the XSS cannot attack the functionality on the Preload script, right? And we will see an example of exploiting this, right? Because then, if there is no context isolation, with an XSS, we can modify functionality from the Preload script using JavaScript prototypes, and then we can gain command execution, or maybe we can bypass something, right? So that's another thing that we will see. So with this, do you see the vulnerability on this? Can you just type in the chat if you see any problem here? Does anybody see anything wrong with this? Inner HTML, exactly. So inner HTML is a sink, right? So it is a place that if you assign user input here, this will result in XSS, right? So this is the vulnerability. And then you have a list of the sources, DOM XSS sources and sinks in this wiki. It hasn't been updated in a while, but still quite relevant. Yeah, so we have that, right? And then let's talk a little bit about electronegativity. So DoyenSec has done a lot of work. It has another security company, and they have done a lot of work on Electron. So they have this tool called Electronegativity. You can install it very easily, like npm install DoyenSec Electronegativity, and then -g to install it globally. And then you can run electronegativity on any application, right? So for example, you can run it on the vulnerable one directory, and then this will run it. It will run pretty quick, and then it will tell you like the list of findings, right? It will tell you all the things that it finds that it's wrong, and I'll just show it now in a moment in the demo. So yeah, you get basically a list like this of things, and you can click on the links to find more information. So with that, let me jump to the demo. So I'm just going to go here. So let's first do npm audit, right? So I'm here like with the first thing that we were talking about, the Smart Notes application. There's nothing particularly wrong with this version. I just chose it because it's old. So this means when we run npm audit, we are going to get some results. So here we have some critical remote command execution and other problems, right? So this is what you can do with npm audit and what the output looks like, right? So it's a quick way to have vulnerabilities anytime you audit any JavaScript application. Now, npm audit, it doesn't work just on Electron, it works on Node.js applications. If you have the source code, it works against Cordova applications. Any JavaScript application that uses npm, you can use npm audit, right? So very useful tool when you're doing security assessments. Now, with electronegativity, first, I'm going to look at the configuration. So when you look at the configuration of an Electron application, you look at the package.json file. And here you're looking for the main entry point. So in here, we can see that main. So the main entry point is main.js. So I can go ahead and open main.js, right? So if I open this, here we can see the web preferences. And we can see that node isolation is enabled and context isolation is disabled. So this is bad. And, just by looking at these, we can already report that these settings are not safe, right? And then we can run electronegativity, right, which looks like this. So you run it like this. There's some cool ASCII art here. And then it runs pretty quick. And then we get the list of results like that, right? So we have, different things, and then we have the lines in which the problem happens. So when you open the file main.js, you can go to line 7 to 21, and all these. So you can go to the lines where it tells you this, right? And then you can click on these links to see more information about each of the problems that it finds. So it's a cool way to find some problems in Electron applications. So with that, let's go back to the slides, move on. So I have more demos coming up. So now let's talk about what XSS means in a desktop application and how to turn XSS into remote command execution, right? So for this, again, if you reach out, I'll send you this as well, the vulnerable application. And when you're running these applications, before you start the application, it's important that you run npm install so that the dependencies of the application are installed, like, for example, Electron, because otherwise it's not going to work, right? So you need to first npm install, and then you can do npm start, and you can run the app from source like this. So with this, we can start sending ourselves some XSS payload. So, for example, script alert 1, SVG unload alert 1. So these typical payloads that you would use against a website to see if there's any XSS, right? And we can open the developer tools, right? So there's this combination of keys that you can use against any app that is an Electron app, right? So if you're familiar, for example, some of the apps that we cover in the course are Skype, Slack, Discord. So all these apps and others, you can use this key combination if they are written, if they are Electron applications. You can do Control-Shift-I, and then this will open the developer tools, and from there you can investigate the application a lot more easily, right? So this is another cool thing to know. And then here we can we have this chat application, right? And we can send ourselves some stuff and we can see what's going on, right? So we send script alert 1, send message, but it is not popping up, even though if we inspect the HTML, we can see the payload is there, right? So it should be working, but it's not working, right? However, if instead of that we use image source X on error alert 1, then it works, right? So this is because the page has already been rendered. So according to the specification, SVG unload alert 1 or script alert 1 is not going to work, whereas image source X on error alert 1 will work because the image has to be rendered, right? And while it is being rendered, it tries to load the value of X, which doesn't exist, and then this results in the alert, right? So with this, we can, let's get this to the next level and try to get command execution, because if we have node integration, this means any XSS results in being able to invoke functionality from Node.js, as I said before. So we can do alert, require child process, exec-sync, and then genome calculator or ID or ls-l or aname-a or any other command that you want to run, and the application will run it. So we have an XSS becomes command execution as long as we have node integration with this technique, right? So this is how the problem looks like, right? So you can run this, you send the message, and then you get this nice pop-up telling you the output of the command that you just ran. So we have code execution. So how to fix this? In general, to fix security vulnerabilities, it's better to use a layered approach. Some people call these defense in depth. Other people don't like that name, but either way, it's really kind of defense in depth in terms of really putting several layers of security in the hope that if one of or two of the layers fail, still one of the other layers will work and will stop the attack, right? So that is the idea. And basically, in this case, we're going to illustrate this with different steps, right? So the first thing would be to disable node integration. So we will still have XSS, but at least it will not be command execution, at least not as easily, right? So we can disable this, and then if we try the payload again, we can see here that require, you can see here alert require child process. So this require is not defined. You can see this very clear error message, and this means that we can no longer invoke Node.js functionality from XSS because node integration has been disabled, right? Then the next thing to do is to implement CSP, right? So with CSP, we can still stop some of the XSS, right? Because we still have XSS. You can still do image source X on alert 1, and this still works if you don't have CSP. So we haven't fixed the XSS yet, right? So we have only disabled node integration. So one of the things that you could do is implement CSP. So it's going to be much tougher, and this will break the XSS on the image, right? So if you do the image source X on alert 1 again, now this is going to fail, right? Because it violates the content security policy. So we're just making it tougher, right? So first we stop the node integration. So that was the first layer. Next layer, we are implementing CSP to make this exploitation more difficult. And now we have more layers, of course, to fix the XSS, right? So now this is going to depend on what the application does, how you fix the XSS, because maybe you need HTML, maybe you need JavaScript, you know, so all these things, right? But the first thing would be to avoid XSS sinks if you can. So avoid inner HTML, location, href, iframe source, and things like that, right? So all those can lead to XSS. So instead, for example, we had inner HTML, so you could change this to text content. So if we change it to text content, then this will no longer be vulnerable, so we no longer have XSS, right? So now if you send the image like that to the application, you can see that the image no longer, the image XSS no longer works, and if you look at the HTML on the page, it's actually all output encoded, right? It's no longer interpreted as HTML. Then the next thing would be to output encode, right? Because sometimes maybe for some reason you need this HTML, right? That is user supplied or where user input can be mixed with or something. So in that case, you can use a library designed to stop this kind of stuff. And a good library for this could be DOMPurify, right? So this is a link to it. And with this, we can like sanitize the HTML, like still allow HTML, but sanitize, right? So this would be how to install it. So you do npm install DOMPurify, and then on the package.json, you will notice DOMPurify will appear. And now we can use DOMPurify to sanitize this, right? So this would be the place in the code where you will make this change for implementing this fix. So you do DOMPurify, require DOMPurify, and then we can like comment these other lines, and on inner HTML we can do DOMPurify sanitize message, right? So allow HTML but no XSS, right? So that's the promise from the Purify. Now if we run the application again with npm start and try some XSS payloads, we can see that the image source X is fine, but then we don't have the the alert one or an error. All that is deleted, right? So DOMPurify goes through all those attack vectors and makes the HTML kind of safe, right? So this is what it does, and this can be useful again in situations where you need to enable, HTML. So with that, let's have a quick demo about this. So this will still be in Ubuntu. Code integration, node integration, sorry. So I'm going to start a vulnerable app, right? So this starts the app with npm start. And now in here, we can try the node integration payload, right? So I can make this a little bit bigger, maybe view, zooming. I'm just going to make it a little bit bigger so you can follow better. That's good. Okay, so now I can go here to Firefox where I already have this open, and I can, I can click on this, for example, and open the genome calculator, run ID, run ls-l, and run uname-a, basically run some commands. So this is the, this, right? So you can see we have XSS. This is the output of the ID command. This is the output of uname-a, so this is this one. This is the output of ls-l, right? And now the calculator will take a little bit longer, and we have it here, right? So because we have node integration, we can basically, let me make this a little bit bigger. So because we have node integration, we can invoke with this require any functionality in Node.js, which essentially results in code execution. Right, so that is why. It's because, as I showed you before, in here, in main.js, we have node integration set to true, and this is why these exec-sync here works, right? So let's move on because I have a lot of more content. So now let's talk about attacking preload scripts. Now for this one, we are going to use a different vulnerable app, which is available in the portal. Again, it's vulnerable 2, so you can download it from here. And here, and basically what we need to understand is this isolation, right? So we have the preload script, and we have the index.html. So if we define a variable on the preload script like ABC, and we assign to it 1, 2, 3, on index.html we can alert it, and it will work. It will show 1, 2, 3. So this means there's no isolation, right? So this is from Masato's slides, which he explained it very well. This is his original presentation. And then when you have context isolation set to true, you have better security because these two environments are isolated, right? So you assign 1, 2, 3 to ABC, and then on index.html, you try to alert window.abc, and this is going to be undefined, right? So this is what the isolation means, and this is good for security, right? So if you have no isolation, you can do stuff like this. You can redefine the index of function. So whenever there is a check with index of, checking that index of is different than -1, we can alter this functionality and then get it, get some sensitive thing like shell open external to open the payload that we want, right? So this will make more sense in the demo, and I'm also going to go in a little bit more detail now. So when the thing to understand here is when there's no context isolation, XSS on the renderer can access and modify JavaScript prototypes used in preload scripts to be able to access more privileged code and bypass certain checks. So now that we have everything set up, let's remove file from the allowed safe protocols, right? So we have safe protocols, we have HTTP and HTTPS, so file is not allowed. And then if you do, hey, look at this, and it is a file URL, and the user clicks on it because there's a linkifier that will make it clickable, then we are going to get that this link is unsafe, right? Because there is this validation of the safe protocols, HTTP and HTTPS, and file is not a safe protocol, so this will fail, right? So it's going to say this link is unsafe and it will not open it, right? So what we want to do is to bypass this, right? So we need to understand how the code in Preload.js works and override some of the prototypes so that we can get our remote code execution using file, right? So this is the code. And we need to override the functionality of index of. So you can see in the comparison that these are the safe protocols defined, HTTP and HTTPS, right? And if the index of link.protocol is different than -1, then it will go to shell open external, right? So by changing index of, so for example, we can redefine index of to function and then return lead, right? So if we return lead, this is always going to be different than -1, which means we are always going to execute shell open external, which in turn means we can get code execution, right? So because we always get a result different than -1. So in essence, this means that if you do, hey, look at this, and then you do file the same thing, but now here we redefine the index of function to return lead, right? Then this will result here in lead, and therefore we bypass the check and we will run this, in this case is a Java file, so we will get this dialog, right? So this might make a little bit more sense in the demo, so let me show you. So this is vulnerable 2, right? So I'm just going to start the app. This is on the Windows VM. I'm just going to make it a little bit bigger. Let's see if this is a little bit easier. Okay, so what we want to do now first is to look at the preload script, right? So we have this check, right? Safe protocols, and then whenever there's a click, we have an event listener. Make it bigger. Zoom in. I think this is a little bit easier to read, yes? Maybe a bit more. Okay, so what we have here is we have this check, right? So we have safe protocols, HTTP and HTTPS. Whenever there's a click, if the click comes from an A tag, right? So this is this check here. If the target is an A tag, so A, href, something, then the link is going to be the target, right? And then the link.protocol, right? If the links is HTTP or HTTPS, right? Then it will open, it will call shell open external. And this is good. I mean, this is a scenario where this would be safe, right? If you do shell open external of HTTP and HTTPS, whereas this would be safe, right? But what we want to do is to modify this index of function using JavaScript because there's no context isolation, right? So if I go, let me see if this is part 1, left 2. If I go to main.js, you can see that context isolation is set to false, right? And this is why we can attack this index of function. We can redefine it so that it returns something else. So the code will always make any click go to shell open external, and then we get code execution, right? So, okay, so let's first try sending this, right? So I'm just going to do, hey, look at this, right? And I send message. And then if I click on it, we get this link is unsafe, right? Because the comparison is actually good, right? What we're attacking here is the lack of context isolation. So if instead of that, I also add this redefinition of the index of function, so that it always turns lead, right? So we have here the XSS, and now if I click on this, we can see that this Java file executed without warnings, right? So this is an example of code execution by attacking a preload script, right? So I cannot go into a lot more detail because I have more demos coming. So, but hopefully this makes it a little bit easier to understand. Now, of course, in the course we go into a lot more detail, but hopefully this gives you a little bit of a head start. Now, and the last one that we're going to cover is vulnerable 3. Now, this application is again available for free in the portal if you reach out. So in here, this is what I talked about before, that the main process is more privileged than the renderer process. So we have the IPC main, right? And then we require Electron. So this is the main process. And then the main process can define what events it's going to listen to, because you saw that the main process and the renderer process, they talk to each other with IPCs. And the way this is done is they define events, right? So for example, here they are defining a listener for get update, right? And then, so the main process has some IPC listener, in this case, get update, right? So it's listening for get update. Then requirement 2, the renderer process exposes the IPC. So the renderer process has to somehow make this reachable from an XSS, right? Because the main process is isolated from the renderer process. So we need some sort of IPC vulnerability to be able to reach this. So in this case, this is again from a real pen test, and this as well, where there was something called Electron send. And this is basically calling the Electron IPC and sending the event and the data without any validation whatsoever, right? So any XSS can use this Electron send to invoke stuff in the main process, in this case, get update, right? So we can, for example, send a script Electron send get update and then get a reverse shell, right? So the JavaScript on the app can invoke functionality of the main process, right, which is more privileged using an IPC, right? And this is the link for this. And then another thing is that the middle click will bypass click events, right? So we saw this click before, and this is good code, actually. The validation is good, but because it's listening to the click event, the middle click will bypass this. So if somebody clicks using the middle click, right, the wheel on the mouse, if you remember, so if somebody clicks that, it will bypass this event, and therefore it will all go directly to shell open external and get code execution, right? So this is whenever this is possible, there's this trick that you can do to send an IPC directly to Electron and then get code execution, right? As long as the user middle clicks, of course. So this is an example for Windows, and it will run like some commands, right? I'll show this in the demo, right? So this is about the middle click, right? So you basically send this message, then this will become a link, and then when somebody clicks on it with a middle click, then you get the output of the commands and stuff, right? So you get the IE user and, you know, listing the stuff in the directory and cat of or type of one of the files here and stuff, right? And then another thing is code execution with lack of context isolation using IPCs, right? So, for example, here we have Electron in browser, shell open external URL. So you can do Electron open in browser of anything you want and get code execution like that, right? So these are all examples of doing the same thing. So basically, this means any XSS on the Electron app will allow listening on the events and send events from the renderer process to the main process with Electron send. So it's always going to depend on what the application does, but yeah. Now, if you're following the slides, you would like pause the video here and try to solve this on your own. But now I'm going to move ahead because we're a little bit short on time. So this is how the code looks like. So there's this on the main process, we have this get update listener as we showed before, and then there's some code here for wheel download and stuff. And in essence, this is assigning executable permissions. So it's getting the file for the update, and then it saves the file. It gives the file executable permissions, and then it runs the file, right? So this is required to process exec file, right? So it's going to give it the executable permissions. It's going to run it because it's supposed to be an update, right? So that is that. So yeah, so this is the IPC main get update, and then it goes to the wheel download, right? And it saves the file in the path, and then it will give it permissions and it will run it, right? So this is basically the idea. So what we need to do is to call get update with Electron send. So we have Electron send exposed in the renderer. We call get update on the main process, which is a listener it has because of this IPC that has been exposed, and we give it a URL to get a reverse shell. And now this is one of the many one-liners. So this is just with bash. We set a FIFO queue, and then we get a reverse shell. So on a terminal, we can set up a netcat listener, and then we click on this. And when the user clicks on this, we will get the code, right? So just moving a little bit fast now because we're running out of time. So yeah, and then we will get on the console like get update, download path, the bytes received and download successful running update, and then on the other terminal we will get the shell back, right? So that is how that looks like. And let me run the demo, and then we will be good to go. So okay, so this is vulnerable 1. And now we're going to run vulnerable 3, right? So I do npm start, and here we want to do, let's see if I can make this bigger. Actually, I think only this is made bigger, right? So what we want to do is to send this reverse shell, right? So I send this link, and then, of course, before clicking the link, you should have here a listener. I have a listener, so I should be good to go. So now if I click on this, now I can go here to vulnerable 3, and we can see it downloads path is the downloads directory. It has downloaded this URL, saved it into downloads with reverse shell.sh, received bytes, download successful, running update. And if I go to shell, here I have a shell, so I can run cat etc password and stuff. So basically, I have a full reverse shell on this, right? So with this, I think that's enough for the demo because we are running a little bit. So join us in November if you want to see the full course. Hopefully this has given you a little bit of a taste about what we are covering and what this is about. We will have a lot of shells, a lot of fun, and a lot of techniques that are real and from the field. And with this, it's time for questions. So again, you have all the information here. This is the ShiftCon link for the course, right? So you can just go to the main website and you will see it there. And if for any reason you cannot make it in these dates, there's also an option for self-paced training, right? But that's up to you depending on what you can do. If you can go in November 23rd and 24th, then just come for the session. So now I'm looking at the chat, and if you have any questions, we have, I think, 5 minutes. On the front end, what is the most efficient way to check for node integration besides using brute forcing of payloads? You will look for this option that I showed before about require, right? So if I go back to the slides, basically you will not be able to do, you can do this, you can do require, you can do alert, require, child process, right? And then if you cannot require, if you get require is not defined, then this means that you cannot invoke Node.js stuff, so you can stop right there. You don't need to brute force anything. If you cannot require, this means you know that node integration is disabled. So that is how you can check it efficiently, because it's just one check at runtime. But the best thing is if you do this key combination that I showed you a little bit more here at the beginning. If you do this Control-Shift-I, this is what is going to show you the developer tools. At the end, you can do this like on Skype, on Slack, Discord, like any app that is an Electron app. You can do this key combination, Control-Shift-I. I think on the Mac is with Command-Shift-I. And then this will give you the developer tools. And in the developer tools, you just need to pay attention, but you would get an error message like require is not defined. So this is how you enable the developer tools. And this, whoops, where is this? Let me, and the error message is here, right? Require is not defined would be the giveaway that node integration is disabled. Does that answer the question? And are there any other questions? So I'll just go to the end. So if you're interested in these applications and the slides and stuff, just send an email to admin@70security.com and I'll give you access to all these for free. Right, that's no problem. Someone is typing, so we're waiting for these are the most possible scripts to identify vulnerabilities. Well, these are some of the examples that we cover in the course. There's, of course, a lot of other ways to attack desktop applications. But, you know, in 1 hour, we can only cover so much. So I just try to give you a taste of different attacks, right? A little bit of node integration, a little bit of attacking preload scripts. But as I showed at the beginning, during the course, we also have like man-in-the-middle, local leaks with files on the file system, reversing binaries, like we have other topics as well. But this would be one of the main ways in which you can attack applications. Of course, in the course, we go into a lot more depth, for example, about attacking applications only using links, even without any XSS at all. And this is explained in a lot of detail. So we go into a lot of trickery to achieve that. Yeah, and that is also actually quite helpful for real assessments, because sometimes you have very well written applications without any XSS anywhere. But if you can get a user to click on something that Windows will run, then you get code execution anyway. So we cover some techniques like that during the course. But these are the attacks that I covered in this session are some of the most you know, useful ones, or one of the most interesting ones maybe for Electron applications. But we cover a lot more in the course, of course. Cool. I think I answered all the questions, and we are a little bit past 1 hour. So if somebody has any more questions, you can ask the question by email, or you can request access to the slides and the apps by email. That's also fine. So whatever works for you. I hope this was helpful, and thank you for joining us.
Abraham, thank you very much for a very interesting webinar. Thank you all attendees for joining us today. Please check our website and our trainings, because you can choose different trainings from our list, and Abraham offer you 3 different trainings. So thank you very much again. Yeah. Have a nice evening, morning, and see you soon.